So we now have covered procedural programming. Let's go ahead and look at how we might look at object-oriented programming. So I'm going to rename this to be 2. I'll rename it save. Okay. So here's how you might add two arrays together with procedural programming. So here we might create an array, we already have A, so I'll call it A1 equals, and then 1, 2, 3, and then int A2 equals 4, 5, 6. There we go. And then with procedural programming, we just have the data, and we might pass in, we might, say print out, maybe we'll get a result. Maybe we'll say int B1 equals add, and we pass in A1, and we pass in A2. This is how we might do something with procedural programming. You take A1, you take B2, you add them together, and return result of B1. All right, so how would we do that in method? Public static void, and I'm going to call it add, and then I'm passing in an int array. I'll call it R1, and array, call it R2, and then I'm going to create a new array. So int result equals new, and then how big is this? There's a subsize 3. All right, I could also just do something like r1.length. Okay, and that'll give me the same thing. It's size 3. So for int I equals 0, I is less than r1.length, I plus plus, and I'll just add these together and put them in results. And so we'll say result sub I equals r1 sub I plus r2 sub I. And then I'll put the result in there, and then I will return result, and then it'll be put in here. And then I'll just print out. I'll use a for loop for int I equals 0, I is less than b1 dot length, and then I plus plus, and then system out print line b1 sub I. All right, boom. There we go. And if we did that, then we would say that this is not void, of course, so we need to pass in, sorry, it needs to be an int array that we're returning, and then everything's happy. Okay, so what are we doing? We're creating A1, passing in A2, and we're creating B1. All right, add them together and then print it out. So what does it show? Let's see here, 5, 7, 9. Well, 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9. So that works. And that's fine. Another way to do this, though, would be to use the idea of an object. See, what I'd like to be able to do is instead of just passing data to a procedure or a method and getting back another procedure, I would like to be able to put some ideas into an object. So I'm going to create a new class. I'm going to just say public class, and let's just call this one my array. Call it my array. And this is just a silly example, but inside this class, it's not going to have a main method. There's not going to be a main method. What we're going to have inside is we are going to have an int array. So it's just going to be R, and that's it. And so when I create an array, my array, I'm going to call it public, and then it's not going to have a return type. It's not going to have a void. It's not going to have anything. It's going to be how I create this object. I'm going to call it my array, and we're going to pass in just some sort of array type. I'll call it R1, shall we? And then we'll say R equals R1. That's it. Now, if I save this, I'll call it, save it in the exact same directory that I'm going to use it. Oh dear, I just changed the name. So save, put it there. There we go. So I can compile it. It compiles, and if I try and run it, it'll say no main methods, applets, or whatever that, however you would pronounce that, MIDIETs found in file. So I can't run this, but I can use it. So I go back to here, and I'm going to create an array. And so I have my array here. Okay, and so at this point, we want to use my array. So I'm going to call it my array. Have to give it some name. So m for my, a for array, 1 equals new my array. Have to make sure and use the new. If you don't use new, then it's not going to work. It basically says I'm going to create a new object here. And just pass in a1, and that should compile fine. Notice that a1 is an integer, and that's integer array, and my array takes an integer array. And whatever the array is, I'm just going to set the value as. So this is called an instance variable. Instance variable. And the whole point of any class is to both store the data, this is the data, and to have functions or methods that actually manipulates the data. At this point, we don't have anything that manipulates it. We just have something that stores it. So I can create my array ma1 and my array ma2, where I'm going to pass in a2. There we go. And so what are we going to do? What I want to do is I want to be able to add things. So I'm going to create int, I'll just call it c1 equals ma1 dot add ma2. So here we have the idea of procedural, where I do add a1, a2, and I add them together, and then it returns b1. That's fine. Well, here I'm doing the same idea. I've got ma1 and I'm adding ma2. The idea here is we're adding whatever's in ma1 to whatever's in ma2. That's pretty cool. And when we're just going to return it into C1. So I already have all the code. It's right here. I'm going to put it in right there into this one. Now, once we get into object-oriented programming, we drop the static. We no longer need static. Static is for procedural programming. And so static is for procedural programming and is not needed for OOP classes. So what I'm going to do here is I'm going to add this together. But you know what? I don't need this first array because it's already here. And so I don't need R1 anymore. I'm just doing R. So this seems really odd, but let's look at how this works. This will compile fine. Go back here, and we have ma1 is just an object that all it contains is an integer array. Ma2 is just something that contains an integer array. Well, I'm passing in my array here, so I can't pass in that. I'm doing ma array. I'll just call it ma for my array. And so because of that, I don't have access directly here. I just say ma. There we go. It's not happy. So what is the type that it has? It has an array here. So ma dot r sub I. And that'll work fine. Now let's look at this carefully. This is kind of weird and confusing, so let's kind of ignore it right now. But conceptually, this makes sense. I have an object called myArray. I have another object called myArray, and I'm adding them together and getting a result. And I say add ma1 and add it to ma2. And so object-oriented programming is a concept, an idea. Anything you can do in procedural programming, you can do in object-oriented programming, and vice versa. So it's a little bit, they're exactly the same in terms of what you can do, but object-oriented programming abstracts. So this object abstracts away. What does it abstract away from? Well, here we have A1, and it's obviously just 1, 2, 3, but when we're dealing with ma1, we're abstracting away from whatever the values are. We're just dealing with an object, and we're adding it to this other object, and we're getting a result. We don't even remember, nor do we necessarily care, what the value of ma1 is. What's in ma1? Well, okay, it's 1, 2, 3 in an array, and what's ma2? It's 4, 5, 6. But the concept here is we're saying ma1, we're going to add it to ma2. Cool. We're adding this to that, or specifically, we're adding this to that, whichever one you want to think about it. But we're adding them together. With procedural programming, we have data, and we're closer to the numbers, and it's harder to abstract away. With object-oriented programming, we create an object, which is more of an idea. And since people deal with ideas, they can do bigger things faster. Object-oriented programming enables people to work better together in big teams. And that's the only reason we actually do it. From a computer side, object-oriented programming slows down the computer a little bit. Not that we really care, because computers are so fast anyway, but it speeds up the person. And just to make sure that we have the right result, I'm going to say system out println C1 colon, there we go, and then print this out, and then instead of B1 it'll be C1. All right, so we add ma1 to ma2 here, which same thing as we have here, so we should have the exact same answer. And there it is, 579 and 579. Okay, the cool thing about this is if we looked at here, we notice that you can do ma.r right here. I can still get access to the array, but I do the dot notation. Notice that system is an object and it does dot notation. So for example, I can do temp equals ma1 dot r. And what is temp? Well, what's ma1? Ma1 passes an A1, so A1 is 1, 2, 3. So ma1 dot r is temp. And so that's what this dot means. It means I get access to the instance variables. What are the instance variables? Well, in this case, it's just r. It's just a single array. So the constructor, this is the constructor, constructor, and that builds the object. And usually what it does is it stores the whatever variables into the instance variables. So the constructor creates the objects by modifying or creating the instance variables. And then you can have as many methods as you want, and methods simply manipulate the data. And in this case, well, I'm manipulating R and changing it by adding another array to it. And so I simply say, okay, I'm creating a new array, making the length of whatever this is, and I'm going through the length of it and saying, okay, this R deals with that one, instance variable, plus ma.r, and ma is what I passed in. If you don't get it right away, then you're normal. Object-oriented programming is very confusing, and it takes a little while to get used to it, and we have an entire class, which is the next class, Computer Science 1410, that deals entirely with the idea of object-oriented programming. So this is just an introduction, and we'll keep going, keep talking about it. But notice this is a class. It's just a class that's used by another class. So we might even call this a library, and it has an instance variables, which is all the data. Constructor, you can have as many constructors as you want. They would all have to say public my array. You can have an empty one, like for example, my array that doesn't have anything in it, and then it simply says r equals new int of size 0. Why you would want an integer array that's empty, I don't know. But they didn't pass anything in, so we can go ahead and create R with no values in it. We have as many methods as we want to manipulate R. And that covers that. And I think that covers it.